Before we focus on solving a linear inequality, I'd like to graph this line, 2x plus 3y is equal to 6. The way this line is written, it's not solved for y, so I'm going to try to use the x and y intercept to get the graph of whatever this thing looks like. So I'll start with, let's say, the x-intercept. Our strategy is to let y equal 0 and then solve for x in our equation. So that is 2x plus 3 times 0 is equal to 6. If I solve for x, after I divide both sides by 2, I get 3. So the x-intercept is here, 3 for x and 0 for y. And likewise, for the y-intercept, it would have to be that x is equal to 0. Again, going back to my equation, I'll put 0 in place of x and solve for y. We get that 3y is equal to 6, and therefore, after divided by 3, y is equal to 2. So there is the y-intercept. Whatever this line is, it has to go through those 2 points. I'll sketch it now. Okay, so I have a rough sketch of the equation 2x plus 3y is equal to 6. To introduce the idea of an inequality, so not just an equal sign, I'd have to change this symbol to like maybe greater than or less than. So I'll actually make it greater than. Let's say this is the actual problem. Not just where is 2x plus 3y equal to 6. When we say equals, we mean the line itself. But what about greater than 6 as well? Like, what does that mean? The answer is going to be either everything that's on this side of the line or everything that is on this side of the line. And we have to decide which side are we going to take. So here's our strategy to do that. I'm going to use something called a test point. I'm going to choose a point that's not on the line, and it could either be here or here. If it's here, and it makes this true, it means that everything on this side of the graph has to work. If it didn't work, it means, well, everything over here has to be the answer. I think probably the easiest point to use would be 0, 0. So I'm going to choose this point, I'm going to plug it into this inequality and see if it makes it true or false. So I'll write that down. My test point is 0, 0. I plug it into my equation. I get 2 times 0 plus 3 times 0. Is that greater than or equal to 6? Like, this is a question. It either works or it doesn't. When I simplify this, I get that 0 is greater than or equal to 6, and this is false. What this means is this point doesn't work. In fact, nothing on this side of the line is going to work. Like, this is all going to be false for this equation. I encourage you to try another point, like try negative 5, 0 in this equation, and maybe 5, negative 5. Any point over here, none of them work. So at this point, I know the answer has to be everything over here, but just to actually see what happens when it's true, I'm going to pick another point. How about we choose the point 0, 5. I'm just going to do a second test point, plug it into this expression just to make sure that it is true. So this is not necessary, but again, just to illustrate what it looks like when it is true. So I'm testing 0, 5. If I plug that into my inequality, I put 0 in place of x, I put 5 in place of y, and I'm asking the question, is this true? The left side is 15. The right side is 6, and it is definitely true that 15 is greater than 6. I mean, it's true that 15 is greater than or equal to it, but this is true. So this point is true for the inequality. In fact, everything on this side of the graph is going to be true. So just to recap, this is our strategy. First, graph the line. The equal sign means that we're actually including it. And this creates a barrier with 2 sides, this side or this side. The only other step is deciding which side are you choosing. You only need one test point to do that. It either works or it doesn't, and that's how you get your answer. So let's try this with a second example. The only real difference here is there's no equal sign on my inequality, and what does that mean in terms of our answer? I'm going to start this the same exact way where I want to get a graph of y equals 1/2 x minus 4. I want to know what that is. That's going to create a boundary. I think since this is solved for y, the easiest approach would be to use the slope, which is 1/2, and the y value of the y-intercept, which is -4. All this means is the graph starts at -4. It has a slope of, I go over 2 and up 1, over 2 and up 1, so I get an idea of what the line looks like. So I'm going to actually sketch this line. Again, I'm putting a point here, using slope to get my second point. Maybe I'll just put a few on here so I get a better guide. But the line goes through these points. Now this is where the difference comes in. There is no equal sign on this inequality, and that means I just don't want to include this line. The way we're going to indicate that is by using a dashed or a dotted line. So when I sketch the line in over these points, I'm just going to indicate that we're not including it by not making the line solid. So I'll sketch that now. So there's my barrier. I just don't have a solid line because there's no equal sign. The only other part of the problem is I need to choose a test point and plug it into this inequality. I could pick a point from here or here, and it doesn't matter. I said 0, 0 is probably the easiest test point. The only condition is that you can't use something on the line, and 0, 0 is not. Let's try it. I'm going to choose as my test point 0, 0, and I'm going to see if it works in my equation. 0 goes in place of y. It also goes in place of x. And I want to know, is this a true statement? So it's a question. Is that true? The left side is 0. 1/2 times 0 is 0, so I'm just left with -4. So 0 less than -4 is false. That means the inequality is false for this point. In fact, it's going to be false for everything over here. And what this means for us is, well, therefore the answer by default has to be everything down here. So this is the answer. It is this shaded region in the plane.